How space elevators could change space travel. Introduction. Hello and welcome to a new frontier. Hey everyone. Welcome to CHIZHIM Science Tech, your ultimate guide to scientific innovation and the future of technology. Today, we're exploring a concept so bold and futuristic that it feels like it was ripped from the pages of a science fiction novel, the space elevator. Just imagine a cable, thousands of kilometers long, stretching from Earth into space, and instead of launching with explosive rockets, we ride up. Sounds impossible? Maybe. But the science is real, the research is ongoing, and the implications are staggering. So fasten your seatbelts as we ascend into one of the most transformative ideas in space travel history. 1. What is a space elevator? A space elevator is a proposed megastructure that would allow payloads to reach orbit by mechanical movement along a tether instead of rocket propulsion. The elevator would start on Earth's equator and rise beyond 35,786 kilometers, where geostationary orbit begins. At the top would be a counterweight, and along the cable would travel electric-powered climbers capable of lifting cargo and humans. The key idea is this: the Earth rotates, and anything tethered above a certain point in geostationary orbit will remain directly above the same spot on the surface. This allows a taut cable to extend upward, held aloft by the balance between Earth's gravity pulling down and centrifugal force pulling outward. It's like creating a cosmic railway, one that connects Earth to space, using mechanics rather than combustion. 2. The origins of the idea. While the idea sounds futuristic, its roots go back to 1895, when Konstantin Tsiolkovsky, a Russian scientist and father of astronautics, was inspired by the Eiffel Tower and imagined a structure extending from Earth to orbit. His version was a giant tower reaching into the heavens, not feasible with existing materials. In the 20th century, the concept evolved. Arthur C. Clarke's 1979 novel The Fountains of Paradise introduced the modern idea of a cable-based space elevator tethered to a geostationary satellite. By the 2000s, interest had grown. NASA commissioned studies. Japanese and European companies formed conceptual teams. Private firms even launched contests for climber designs. What began as visionary fiction slowly matured into serious scientific inquiry, proving that imagination can spark innovation. 3. The science behind it. The physics behind the space elevator are both elegant and complex. A tethered cable extending from Earth through geostationary orbit is kept taut by the balance of forces. Earth's gravity pulls down on the lower part of the cable. Centrifugal force, due to Earth's rotation, pulls outward on the upper part. The center of mass of the cable lies at geostationary orbit, 35,786 kilometers, ensuring it stays fixed above the equator. The structure would include a base station, likely at sea, to avoid storms and anchor it near the equator. A climber system, possibly powered by laser beaming, solar arrays, or magnetic induction. A counterweight at the far end, possibly a satellite, asteroid, or extended cable. This isn't science fiction math, it's orbital mechanics in action, a clever dance of forces that could allow us to ride to the stars. 4. The material challenge. The biggest obstacle to building a space elevator? The cable. It must be incredibly strong, incredibly light, capable of withstanding tensile forces greater than any known material can bear. Enter advanced materials. Carbon nanotubes, CNTs stronger than steel, lighter than aluminum, and with a tensile strength of over 60 GPa. Graphene, a one-atom-thick sheet of carbon, with strength that defies imagination. Diamond nanothreads, potential future contenders, offering extreme resilience. But here's the problem. While these materials have been made at microscopic scale, we haven't yet figured out how to manufacture them in continuous strands tens of thousands of kilometers long. Building the cable is like creating a spider's thread that stretches from Earth to orbit, and it has to be stronger than anything we've ever built. 5. Advantages over rockets. Why go to the trouble of building such a massive system? Because it could revolutionize space access. Lower cost. Rockets cost up to $10,000 per kilogram to launch. A space elevator could reduce this to under $100. Zero fuel. No need for heavy fuel or explosive chemicals. Eco-friendly, no emissions or pollution during ascents. Safety, no launch explosions, lower G-forces for cargo and humans. Frequency could operate like a train system, continuous, reliable, and scalable. Space elevators are not just cheaper and safer, they're a leap toward truly sustainable space travel. 6. Costs and funding. Though cheaper than long-term rocket costs, space elevators demand a massive initial investment. Estimated build cost, $10 to $100 billion. Maintenance and operation, minimal compared to launch systems. Global funding sources could include government agencies, NASA, ESA, JAXA. Private corporations, like SpaceX or Blue Origin. Public-private partnerships. International coalitions. Japan's Obeyoshi Corporation plans to build a space elevator by 2050, with several phases of construction and material testing already underway. Just like high-speed rail and bridges changed the Earth, this megastructure could change our place in the cosmos. 7. Potential applications. A working space elevator would unlock endless applications. Orbital logistics, continuous supply to satellites and stations. Moon and Mars missions, use Earth orbit as a staging point. Space tourism, safe, affordable transport for civilians. Manufacturing in microgravity, build ultra-pure materials, drugs, and electronics. Solar power satellites, construct massive clean energy collectors in orbit. It's not just about reaching space, it's about enabling everything that comes after. 8. Threats and risks. Challenges include space debris, could sever the cable unless tracked and avoided. Atmospheric events, hurricanes, lightning, and high-altitude winds. Terrorism and warfare, potential targets for sabotage. System failure, a cable collapse could be catastrophic. Solutions: active debris shielding. Automated defense systems. Laser-guided cable retraction during storms. AI-controlled emergency protocols. Like any great structure, it needs defense, maintenance, and foresight. 9. Where we are today. Progress is slow but steady. NASA's Institute for Advanced Concepts, NIAC, has supported studies. Japan's space elevator competitions focus on climber robotics. Cambridge and Stanford researchers are modeling tether dynamics. Private startups like Liftport are working on Earth-to-orbit prototypes. Each breakthrough brings us closer to turning this dream into a real, functional pathway to space. 10. Future vision, a space elevator world. Imagine cities powered by orbital solar collectors. Students taking class trips to orbit. Cargo ascending gently to a lunar launch pad. Mars colonies supported by an Earth-based supply chain. The space elevator could mark the dawn of an era where space is not a frontier, but simply the next floor up. 11. Debate and controversy. Critics say, the materials are decades away. Too fragile for Earth's chaotic weather. Too costly with uncertain ROI. Supporters argue, the same was said about space travel, the internet, and airliners. Private funding could accelerate development. Early proof-of-concept elevators on the Moon or Mars, with lower gravity, could pave the way. The debate is fierce, but progress often begins at the edge of impossibility. 12. Conclusion: the gateway to space. The space elevator is more than a machine, it's a symbol of what humanity could achieve when we aim high enough. With bold vision, scientific grit, and global cooperation, this incredible idea could transform us from a spacefaring species to a truly space-living one. Thanks for joining CHIZHIM Science Tech on this epic journey into the future. Don't forget to like, comment, and subscribe for more groundbreaking explorations into the science of tomorrow. Until next time, keep looking up.